Welcome to section 2.4, absolute value function. All right, so some properties of the absolute value that we have are the following four. So if you have two numbers being multiplied inside of an absolute value, you can split them up into the multiplication of two separate absolute values. Again, this is for multiplication between two numbers on the inside, not addition. Also, the absolute value of A is equal to the same thing as the absolute value of the opposite of A. And then for 2, very similar to number 1. Again, if you have the division of two absolute values, you can split it up into the division of one absolute value divided by the division of the other one. And then for number 4, the addition of two items in the absolute value bar are greater than or equal to the addition of those two items inside the absolute value bar. So let's take a look at the absolute value of x equals to 4. So one thing to remember for absolute values is talking about the distance from 0. So again, this is 0, and the absolute value here is saying how far is that number from 0? Well, that number is 1, 2, 3, 4 units from 0. 1, 2, 3, 4 units from 0. So either the positive or the negative are both 4 units from 0. Again, just the distance from 0 is what we're talking about when we're looking at absolute value signs. So for solving equations with absolute values, if the absolute value of u is equal to some number, with that number being greater than 0, we'll look at cases when it's not, but for now, with it being greater than 0, then we know we can split it into an OR statement, with u equaling that number or u equaling the opposite of that number. Just like above here, with our absolute value equal to 4, it was either negative 4 or positive 4. So for example, 1, let's take a look. We have the absolute value of 3 minus 4x equals 7. So again, we can split this up using our rule, equal the positive or the negative. 3 minus 4x equals positive 7, or 3 minus 4x equals the opposite of 7. Again, either the positive or the negative version. So let's go ahead and solve each of these. And again, it's important to put OR in between when you're solving this. So let's see, I'll minus 3 from both sides. Negative 4x equals 4. Dividing both sides by negative 4, we get that x equals negative 1. Now, or my next solution, same type of problem solving, minus 3 from both sides, except this time it's going to be negative 10, and then dividing by negative 4. We can simplify the negative 10 and the negative 4, and we get x equals 5 over 2. And we're done. So let's take a look at the next one. Now you might be tempted to try splitting this up, but at the moment, notice what has happened. What is the difference between A and B? For A, our absolute value was already by itself equal to a number, which again is how our directions are set up here, or our definition. At the moment, my absolute value is not by itself. It is being surrounded by that negative 2 and the plus 11. So my goal is to get it by itself first, and then I can switch it into the positive or negative for solving. So again, that is going to be my goal. First things first, I'm going to go ahead and decide to minus 11 from both sides. And then once I've done that, I'll go ahead and divide by the negative 2 to get my absolute value by itself. So that's going to be negative 4. Dividing by the negative 2. The absolute value of x minus 5 equals 2. So again, we can split this up into an OR statement. X minus 5 is equal to the positive, or x minus 5 is equal to the negative version. Again, taking the positive or negative of this one. Positive, negative. And then solving. Add 5 to both sides, and we get x equals 7. Or, again, remember your OR. Doing the same thing here, adding 5 to both sides, and we have x equals 3. All right, again, important to get your absolute value by itself. So now let's take a look at some special cases. If for some reason we have our absolute value and it's equal to 0, so the absolute value is equal to 0, the k value at the end, there's only going to be one solution for our problem. If our absolute value is less than 0, there's going to be no solution. Why is this? Well, let's again take a look at a visual of our graph. Absolute value is talking about the distance from 0, right? So if I'm saying my distance from 0 is 0, well, that's just going to be 1 point. That's as far as you can be from 0. Boop, you're right at 0. But if I'm talking about my distance from 0 is less than a negative number, can you be less from 0? You can't. Again, distance from 0 is always positive. You're always talking about positive distances. You can either be directly at 0, or you can be a positive unit of distance away from 0. So if it's less than 0, there's no solution for that absolute value. So for the first one, we have it, and it's set equal to 0. Well, we know this is going to have one solution, so we'll just go ahead and set that up. 5x minus 1 equals 0. If you tried to set it up with or 5x minus 1 equals negative 0, that doesn't really matter because 0 isn't a positive or a negative. So again, we'll just set that up with the 5x minus 1 equals to 0. Because again, we're just going to have one solution based on that case. And when we set that up, adding 1 to both sides to solve, and then dividing by 5 to get x by itself, and we get x equals 1/5. For the next one, we have our absolute value, and it is equal to a negative number. Again, we know this is not possible. So because this is not possible, we're just going to go ahead and say no solution. And we're done. Now, let's take a look at another case. If we happen to have an absolute value equal to another absolute value, what do we do? Well, we just do u equals to w, or u equals to the opposite of w. Pretty much the exact same thing we've been doing before. So let's go ahead and do that. We'll treat this as u, and we'll treat this as w. It actually doesn't matter if you switched it, you get the same answer, but let's go ahead with this. So that means 3 minus 5x is going to equal 2x minus 9, or, again, it's important to write or. 3 minus 5x equals the opposite of 2x minus 9. All right, let's go ahead and solve. Getting our variable to one side, I'll minus 3 from both sides. I get negative 5x equals 2x minus 12. Adding 2x to both sides. And I have negative 3x equals negative 12. And then getting x by itself, let's divide by 3. X equals 4. Let's solve the other side. I'll go ahead and distribute that negative first. Negative 3 minus 5x equals negative 2x plus 9. Now let's see, I'm going to go ahead and minus 3 again from both sides. This time I'll add the 2x on the same step. So 5x plus 2x is going to be negative 3x equals, and the negative, or the positive 9, minus 3 is going to be 6. Dividing both sides by the negative 3, x equals negative 2. Oh, just saw a small error there. We should be minusing 2 from both sides on this problem. Let me go ahead and erase this. Hopefully you caught that. Okay, so again, waiting for my pen to catch up. All right, so again, minusing 2 from both sides. And we should get negative 7 equals negative 12. And then dividing by the negative 7, we'll get that x equals 12 over 7. All right, that should be good. Careful with those signs, they are snicky. All right, so let's take a look at solving inequalities. Again, some just sort of cases when we're looking at inequalities. So before we were just working with an inequality and an equal sign, which again was just talking about strictly the distance that's 4 units from 0, which would have been this point and this point. These 2 points are strictly 4 units from 0. Now we're bringing in equalities, or inequalities. So we're bringing in inequalities, which are these symbols right here. And let's take a look at the first case. This is talking about x should be less than 4. Again, so my solutions should be less than 4 units away from 0. Well, what's less than 4 units away from 0? Anything inside of here is going to be less than 4 units away from 0. Again, the x value should be less than 4 away from 0. So those are all these values in here. Let's take a look at the next one. This is talking about all the values should be less than or, and what does that symbol down there mean? Equal to. So they should all be less than or equal to 4 units away from 0. So here's the less than away from, or less than 4 units, and then this one is equal to. So again, we fill in this bubble when we're using that equal to symbol on the bottom, the filled in bubble. If we don't have that equal to symbol on the bottom, we leave our bubbles empty, like we did in this one right here. Okay, so let's take a look. If u is less than k, with k greater than 0, again, remember we're always talking about our absolute values greater than 0, then we're going to rewrite it as u on the inside is less than the positive and greater than the negative, which makes sense for our graph up here, right? It should be less than the positive on the inside and greater than the negative. Same thing with when we have it equal to k. The only difference is that we're going to use equal to k in our answer. Okay, so one thing to note, values between the inequalities are called and statements, which are intersections. So this is the same way to write this. Because x is greater than negative 4, which is right here, and x is less than 4, which is right there. So again, same thing for an and statement, not an or statement. Be careful. So if we were graphing x is less than 4, here's 4, and again, we're not going to fill it in because it's just less than, and it's all of these values here. Now, if we were to graph x is greater than negative 4, this is negative 4, our boundary, and we know x is greater than. Again, we don't fill it in because it's not an equal to. And then if I wanted to look at the intersection of those two, the and, again, I'm looking at where they intersect or they overlap. I'll go ahead and sketch that in here. The intersection of these two graphs is this point right here. Or not this point, this interval right there. And so that interval is, again, from negative 4, not including, all the way up to positive 4. And that would be an and statement. So it's only where they agree or intersect. Let's take a look at example 4. Alrighty, so solving. Okay, we might be tempted to switch it right now, but again, we always want to have our absolute value by itself first, and what's keeping it from being by itself is that negative 5. So let's get that negative 5 to the other side, and then we can go ahead and solve. To get it to the other side, let's go ahead and add 5 to both sides. And then we have 2x minus 6 is less than 8. Okay. Because it's less than, we can go ahead and switch it to an and statement, which means I'm just going to copy paste what's on the inside, 2x minus 6, then copy paste that less than 8, and again, just make it greater than the opposite, bounded by the negative version and the positive version. And then let's just go ahead and solve. So again, we want x to be by itself, so to get it by itself, I'll add 6. Carefully, you have to add it to all 3. So then that's going to be, let's see, negative 2 less than 2x less than 14. And then, okay, to get x by itself, we got to divide by that 2 from the inside. We don't have to worry about switching the inequality signs. That only happens if you're multiplying or dividing by a negative number. And there we go, bounded by these values. So if I was to graph this answer, let's see. I always want to indicate where 0 is, and then you can just write the other values, so negative 1 and 7. And we know my values are in between this, but not equal to any of them. So there we go, and that would be the graphing of my answer. Now, if I wanted to do interval notation, what would that look like? Well, reading from left to right with interval notation, left to right, what do we first see in our boundary? We start with that negative 1. And then it continues, and then it stops at 7. But we don't include it, so actually I shouldn't be using that brace there. We don't include either of them. They're an open bubble, so I'm just going to go ahead and use my open parentheses to indicate that boundary. And that would be interval notation. Easiest to read if you graph it first. Now let's take a look at the next one. Again, we always want to get our absolute value by itself, and right now it's not by itself. What's keeping it from being by itself is that 2 and the 3. So first, I'll go ahead and minus the 3 from both sides. And I get the absolute value is less than 26, but I still have that 2 being multiplied to it. So let's go ahead and divide by 2. And when I do that, I get absolute value of 1 minus 4x is less than or equal to 13. All right, so now it's less than, which means we know it's going to be an AND statement. So we'll just copy paste what's on the inside, less than or equal to 13, and then again add on that it's greater than the negative version. Okay, so now we have that compound statement. Let's go ahead and get x by itself. Well, minus 1 from both sides, again trying to get that inner value just to be x. And then, let's see. So let's get x by itself. We'll divide by negative 4. Ooh, when I divide by negative, what happens to my sign? It has to switch. Careful, we divided by negative. We got to flip our signs. So simplifying this, that's going to be 14 divided by 4. They're both divisible by 2, which means we have 7 over 2 greater than or equal to x, which is greater than or equal to negative 3. And then again, we could graph our answer. So we know here's 0. We're looking at negative 3 and 7 over 2. I don't really care exactly where that is. I'm just doing a rough estimate. And we know that my x value is in between these two, but it's also equal to these two. So let's go ahead and fill in those bubbles. And then to do interval notation, again, reading from left to right. From the left, we first see that negative 3, and we're including it. And then our graph continues until it hits, boop, 7 over 2, and again, includes it. And that would be interval notation for my graph. So now let's move on. Again, if we were graphing the absolute value of x is less than 4, we're talking about less than 4 units away from 0, which would be this. But now I'm talking about something else. I'm talking about x is greater than 4 units away from 0. So how do we describe greater than 4 units away from 0? Well, all these numbers are greater than 4 units away from 0, and all these numbers are also greater than 4 units away from 0. So that would be how you would graph x is greater than. And then if I had the same thing, but I had an equality sign on the bottom, it'll be the same thing. We're including 4, but also greater than. So the only difference here is, again, we fill in the bubble when we have greater than or equal to, and we leave it open if we have less than or equal to. Or I mean, if we just have less than or greater than. So again, that little sign on the bottom there tells you you can fill in the bubble. Alright, so we're not going to write the AND statement, which is the intersection for AND. That would be the empty set. So for these answers here, when we have x is greater than, these are going to be OR statements, not AND. So we were working on AND statements, now we're moving on to something called OR statements. So let's take a look at example 5. We're going to go ahead and solve. So again, my absolute value is not by itself. That's the first thing I want to do. I want to get that 3 and that 14 away from my absolute value. I want that by itself. So feel free to pause the video and try work on this by yourself and check in with me. Okay, so hopefully you pause it and try this out by yourself. And let's have 9, and then dividing by 3 to get everything by itself. We have x minus 7 is greater than 9 divided by 3, which is 3, not 6. All right, so again, oops, I got rid of those absolute values too quickly. It's still in the absolute values, so to get it out of the absolute values, we have to write an OR statement because my absolute value is greater than. So what would the OR statement look like? Well, we know it needs to be greater than the boundary of 3, or it'll be less than the opposite of 3. Just like above here, it was either greater than the positive or less than the negative when we graph it. Okay, so let's go ahead, continue solving, add 7 to both sides. We get x is greater than 10, or, again, write that or. Add 7 to both sides, and we get that x is less than 4. So how would we graph this? Let me go ahead and leave some space here. Actually, I'll graph it down here, and then I'll erase it. So on our number line, we have 0, 4, and 10. And we're looking at x is greater than 10, and x is less than 4. So that's how we would graph it. Now, how would we do interval notation? Well, again, interval notation is reading from left to right. So first we start with the arrowhead. That would mean negative infinity. We continue till 4, but then we stop at 4, and we don't include it, so I'll use the open parentheses. Then there's that little skip in the jump. So we'll have to union our answer. And then again, we start at 10, but we don't include 10. And then it keeps going to that arrowhead, which again means infinity. So that would be interval notation. Let me go ahead and erase that. So let's see, moving on again to the next one. Our absolute value is still not entirely by itself. We got to get rid of that 7. So let's go ahead and do that. We'll add, or subtract 7 from both sides. Okay, 1 minus 4x is greater than or equal to the 5, and then again setting it up. So we're going to first write down the inside value. It should be greater than the 5. Or again, copy paste down the inside value. It's going to be less than or equal to the opposite of that value. Again, basing it off of our graph, it's either greater than the positive or less than the negative. And solving for 5, I'm going to go ahead and minus 5 from both sides. Then I'll add 4x to both sides so I can avoid trying to divide by a negative. So that'll be, let's see, negative 4 is greater than or equal to 4x, dividing by 4. And I get negative 1 is greater than or equal to x. Now solving the other side. Minus 1 from both sides, and we get negative 4x is less than or equal to negative 6. Then divide by negative 4. Oops, when we divide by negative 4, what happens? We need to switch our inequality. Yep, very good. And divide by negative 4. Then we can simplify that fraction. That's going to be 3 over 2. Again, if you need any help simplifying fractions, just send me an email and I'll give you a worksheet for that. All right, so there we go. We have it, our OR statement. So let's graph this line. What are we looking at? We're looking at negative 1 and 3 over 2. And my graph is saying that x is less than the negative 1 or equal to, and it's greater than or equal to the 3/2. So how would I graph this in interval notation? Well, starting with that negative infinity, we continue until we hit, boop, negative 1, include it, so we use that brace. Union, use a little bracket, 3 over 2, and we continue on till positive infinity. All right, okay, I'm going to go ahead and erase my graph here, not my graph, my interval notation, and let's take a look at some special cases. So we have some bunch of random little special cases. Try pause the video and see what answer you think you would have. Keep in mind, again, we're talking about the distance from 0. So for example example 6, part A, we're talking about the absolute value less than negative 1. Is that possible to be less than negative 1 away from 0? The answer is no, so this is going to be no solution. Again, because we're talking about my absolute value being a less than, no solution. Next, again, we're looking at an absolute value and we're saying it's less than or equal to negative 1. Again, that's going to be no solution. Let's take a look at the next one. This time, again, my absolute value, and I want it to be less than a 0. We can't be less than 0, which again would be like a negative value. So this one, again, is going to be no solution. My next one. This one's saying my absolute value needs to be less than, or equal to 0. That changes things. It can still technically be equal to 0. So because it can still technically be equal to 0, even though we can't do the less than 0 aspect, we can still do the equal to aspect. So here's going to be the small little answer when it's equal to 0, which when I go ahead and solve that, that's going to equal 4. So we're going to have x equals 4 as our answer for that one. So just the one single point. Next, we're looking at our absolute value is greater than negative 1. So you might say it's still greater than a negative, but there's still those numbers in between negative 1 and 0 that we can't account for. So because of that, we're going to go ahead and say it's not defined, no solution. Another time. The absolute value of x minus 4 is greater than or equal to negative 1. Still in that range, we don't have a definition for that, and there's no solution. Next, last two. So absolute value of x minus 4 needs to be greater than 0. Well, this technically does make sense. It could be a greater than a distance of 0 from 0. So let's see what this would look like. Again, with the greater than concept, and with greater than, we look for or. So we have x minus 4 greater than 0, or x minus 4, again, is less than the opposite of 0, which is just 0. And then solving, we'll get x is greater than 4, and x is less than 4. Which may seem odd, but let's go ahead first and graph this before we question it too much. Give me 0 and 4. And I'm saying that x needs to be greater than 4, and x also needs to be less than 4. Which actually, that makes sense now that we graph it. It's everything except for 4. So in interval notation, this would be negative infinity up to 4, but not including it, and then continuing on from 4 to positive infinity. Okay, so that one makes sense. Let's take a look at the next one. Now we're talking about x minus 4 greater than or equal to 0. Which, let's see, does that make sense? Well, again, it's just graphing. It's going to be the exact same problem, except we're going to include 4. So let's just go ahead and include 4, which would actually be negative infinity to positive infinity. Okay, so again, those are some special cases that we're looking at. So let's take a look at the absolute value function a little bit more. So again, the absolute value function, there's two cases. If what's on the inside is a positive, it's just going to be x. We're not going to change it. But if what's on the inside is less than 0, we have to first take the opposite of it when we take it out of the absolute value signs. So again, this is if we're trying to get rid of the absolute value sign. First, we're going to look on what's inside. So look at the inside sign. Is it a positive or is it a negative? The thing on the inside. When you discover it's a positive, you can just keep it as the regular value x. If what you discover on the inside is a negative, then you're going to need to change that to the opposite of the value. So let's take a look at our problem first. Well, these are all numbers that I can simplify. So let me go ahead first and simplify that. That's going to be 2 times 3 minus x is negative 7. Sorry, that was 3 minus 10 is negative 7. And then we can go ahead and multiply that. That's 2 times negative 7, which is negative 14. Okay, let's see what's on the inside. It's a negative number. So again, if it's negative on the inside, what do? We have to take the opposite of it. So again, we can drop the absolute values, but we need to take the opposite of it. So again, the opposite of what's on the inside. And then what's the opposite of negative 14? Well, that's just 14. And does that make sense? Yes. Absolute value of negative 14 is 14. Let's take a look at B. So this we have the absolute value of pi minus 5. Do we know what pi is? Well, we don't know an exact number, but we know pi is roughly 3.14. So we're saying 3.14 minus 5. Now again, ask ourselves, is this going to be a positive or a negative number? Well, 3.14 minus 5 is actually going to end up being a negative number. So since what's on the inside is negative, what do we have to do to drop the absolute value signs? We have to take the opposite of it. So the opposite of pi minus 5, again, we drop the absolute value signs, but we have to take the negative because, again, this outcome would be a negative number. And then we could go ahead and simplify if we wanted to, and we get negative pi plus 5. And that would be it. So now the last piece, let's take a look at the absolute value of any function. So if you have some function, f of x, and we decide to take the absolute value of it, what happens? Well, my function is going to stay the same, just f of x, if those values are greater than 0. It'll stay the same. However, we're going to take the opposite of it if those values are less than 0. So let's take a look at my graph here. I have a graph, f of x, given on this little plane. It goes, and now I want to find the absolute value of it. So how would I do that? Well, again, the absolute value, you're just going to take the opposite wherever it's negative. So first let's determine where f of x is negative. Remember, f of x is my y values. So anything below here is going to be when my f of x is negative, which means this part of the graph here is where f of x is negative. So I'm going to take the opposite of those values to get the absolute value function. Let's see, what's the opposite of, let me change my pen. What is the opposite of 0, negative 1? Well, the opposite of 0, negative 1 is going to be 0, positive 1. So my graph is going to pop up somewhere like this. Boop. But again, look, this is all still negative down here. So we'll find these 2 points. That's going to be, that is 3, negative 1. And this is 2, negative half, that looks like. Again, we're just going to take the opposite of it. So that'll be 3, positive 1, and this will be 2, positive half. And my graph will continue up like this. So that is my absolute value function. It's still the part where it was positive, and then the reflection part where it now becomes the opposite of the original value. So, next we're going to state the domain, and I'm going to do range of the f of x and absolute value of f of x. So, for f of x, my domain of f of x, let's see. All my values that are horizontal, so that's going to be from negative 4, including, all the way up to 3, including. Now, what's my range of the original function? Well, that's, again, these values. So we start at negative 1, and we continue until 3. Negative 1, and we continue till 3. Next, let's take a look at my absolute value function. Let me just go ahead and highlight it so you can remember where it is. So my absolute value function was, again, these values here, the new ones that we graphed. So my domain for that, it's actually not going to change too much. So it's going to go from negative 4 negative 4, and it's going to continue on until 3. And then my range is going to be a little different. This time we're going to start over here at 0, because that's where my graph starts, and it continues on until 3. So from 0 to 3. All these values in between. That'll be from 0 to 3. And then that is it. We're done for this section. Again, if you have any questions, please feel free to email me. I can give either worksheets that'll help you a bit extra, or we can just do a Zoom office hour to talk about a problem. Again, email me if you have any questions.